Welcome to another video, still on the time series. Today we would be focusing basically on seasonal variation and forecasting. Basically, we are going to apply uh, whatever we've learned previously. That's finding the trend either by using the method of moving average or by using the linear regression equation to find the trend, to also find the seasonal variation, either by using the additive model or the multiplicative model. So now let's zoom into today's business. So the seasonal variations are both short-term fluctuations which occur regularly and periodically within a period of less than 1 year, such as days, weeks, months, or quarters. Climate and weather conditions, social customs and traditions and habits of people at different parts of the year are the main factors responsible for seasonal fluctuations. The purpose of studying seasonal variation is to determine the effect of seasonal swings on the value of a given phenomenon, to focus short-term fluctuations and to eliminate them for the study of cyclical and irregular variation. Seasonal variation is measured in terms of an index called seasonal index. It is an average that can be used to compare an actual observation relative to what it would be if there were no seasonal variation. One of the methods used to find a seasonal pattern is the ratio to moving average method, or you may use the linear regression to determine the seasonal pattern. So what basically they are trying to find is we are trying to uh, remove the seasonal variation in our data. What will be our actual data if there was no festive season? What will be our actual data if there was no rainy season? What will be our actual data if habit of people hasn't changed or remained constant over successive periods? So we'll be using the additive model first. When you're done, we move on to use the multiplicative model. So now let's look at the step in estimating the seasonal variation, which is measured by an index, that the seasonal index. Then we will then use it for forecasting. So the first step is to calculate the trend in the data, either using the moving average method or the regression method, for which we've done in a previous video. Calculate the value of the deviation or the variation for each year or quarter. This is given by your S is equal to Y minus T. So that's your seasonal. This is given by S equal to Y minus T. So where your S is your seasonal index and your Y is your actual data given, which is given, and your T, that's your trend values, which you solved either by using the moving average method or the regression method. When you're done finding the seasonal index, move on to find the average of the quarterly deviation or the variation. if the total of the quarterly deviation obtained in step 3 above is not equal to 0, then we adjust one or more of the quarterly average so that their sum add up to 0. So you can use this adjustment factor. That's the average plus or minus the grand average, depending on the sign you will get. When you're done finding, then we then go ahead to deseasonalize the data. How do we deseasonalize the data under the additive model? It's your actual sales minus your seasonal index. This one becomes the what? Adjusted seasonal index. Estimate a new regression equation of the deseasonalized y values on the time period t. Note that the time period here will be in array of 1 to in that order, depending on the number given. Now predict future values by using the new regression equation. So based on the steps we've outlined here, now let's apply this in an illustration. The table below shows the sales of new cars by quarters during a period of 3 years. So we have year 2014 to 2016 and quarter 1 to quarter 4. We are to use the moving average method, that's using the additive model, to determine the deseasonalized sales and establish a trend equation using this deseasonalized sales. When you're done, we estimate the sales to be expected for the 4 quarters of 2017. So now let's solve this question. We are going to use the ratio, the moving average method. So now we have the year, we have the quarters, then we have the y value, that's the sales. The sales is the actual y values. We have here 2014, which is quarter 1, and we have quarter 2, quarter 3, and quarter 4, with a value of 55, 76, 61, 77. Then let's move on to 2015, quarter 1, 2, 3, and 4. Also with 54, 65, 54, 65, 52, 81. Then lastly we have 2016, also quarter 1, also quarter 4, with a figure of 5983, 83, then 7893, 93. So now the data was collected over a period of 4 quarters. So it's more advisable to move in a period of 4. So now we are going to have 4 period moving average. And because it's now an even number, we now have to find 4 period centered moving average. Now this becomes our trend values. Okay, so now let's move in 4. So for the first one is 55 plus 76 plus 61 plus 77. giving us a value of, so now the value becomes 66, 66. I'm going to write it in between this. So 66, 67.25. Then the next one is 76 plus 61 plus 77 plus 54. Divide by 4, also giving us, so write it in between this, 67. Next one is 61 plus 77 plus 54 plus 65. 64.25. The next one too is 77 plus 54 plus 65 plus 52. Divide by 4. So write it in between the 65 and the 52. '62. The next one is 54 plus 65 plus 52 plus 81. Divided by 4. Also giving us 63. And then we have 65 plus 52 plus 81 plus 59. Divided by 4. 64.25. The next one will be 52 plus 81 plus 59 plus 83. Divided by 4. 68.75. 81 plus 59 plus 83 plus 78. Divided by 4. 75.25. 59 plus 83 plus 78 plus 93. Divided by 4. Also in between 2 and 3, we have 78.25. Okay, so now let's center this, which becomes our trend values. We are going to move into, so 67.25 plus 67 divided by 2. So in between the 67.25 and the 67 lies the third quarter in 2004. So this value is for the third quarter in 2014, which is 67.125, which means that for the first two quarters in 2014, we have no values. We have no values. So our next value is going to be between the 67 and the 64.25, which also have a period of the fourth quarter. So 67 plus 64.25 divided by 2, 65.625. So the next one is 64 63.25 plus 62 divided by 2, 63.125. 62 plus 63 divided by 2, 62.25, 62.5, 63 plus 64.25 divided by 2, 63.625, 64.25 plus 68.75 divided by 2, 66.5, 66.5, 68.75 plus 75.25 divided by 2, 72. Then lastly, we have 75.25 plus 78.25 divided by 2, we have 76 so 76.75. So when you're done finding the trend values, we'll go ahead to find the seasonal index or the specific seasonal index. So we have the seasonal